So what we're going to look at today is factorizing by grouping. And in order to understand how we work with factorizing by grouping, it's important that we develop an understanding of what we're actually doing when we're dealing with numbers, right? So let's just say 15 times 23. Let's have a look at this, right? So 15 times 23. So if we have 15 times 23, if we're going to multiply this out, typically what we do is we multiply the 5 by everything first, and then we multiply the 10 by everything. Okay? So 5 by 3 gives us 15. 5 by 2 gives us 10. 10 plus 1 gives us 11. Now we're going to look at the tens. So looking at the tens, we'll put down a 0 because it represents the tens now. And now we look at the tens. 1 times 3 gives us 3. And 1 times 2 gives us 2. We have our we have our 115 and our 230. So what we're going to do is going to add them together and see what we get. And we'll get 345. Okay. So this is just showing you what we do when we multiply double digits, right? Okay, so you should be able to see there that we're multiplying our 5 by everything to get this. And then we're multiplying our 10 by everything to get this. Okay. What I want you to understand is how we actually break this up. So I'm going to show you there with numbers again, right? So just another way to represent long multiplication. So 15 multiplied by 23. Effectively what I'm doing is I'm multiplying my 10 by 20 gives me 200. Okay. 10 by 3 will give me 30. Okay. And down here you can see 5 by 20 will give me 100. And 5 by 3 will give me 15. If I was going to add all of them together, I get 200 plus 100 is 300. 300 plus 30 is 330. 330 plus 15 is 345. Okay. So that's two ways of representing long multiplication. I'm going to show you one more way. And the next way is going to be this one. Okay. So what we can do there is 15 multiplied by 23. I can break up my 15 into 10 plus 5. And I can break up my 23 into 20 plus 3. And what I can do is 10 times everything in the second, which is 20 plus 3, and plus 5 by 20 plus 3. Okay, so it's the exact same as what we did earlier. So 10 times 20 gives you 200. 10 times 3 gives you 30. 5 times 20 gives you 100. And 5 times 3 gives you 15. So you can see there what we're going to end up with is 100 plus 200 is 300. 300 plus 30 is 330. 330 plus 15 is 345. Okay, so that's just 3 different ways of representing how we do multiplication, long multiplication, and you can see them there. And the reason why I'm showing you that is because factorizing by grouping isn't a new topic. It's something that you've actually seen before, and it's how you split terms. Okay, so it's how you split up terms. And what I mean by that is very similar to the last example there, how we split things up, right? Okay, so I'm going to move on. So factorizing by grouping, okay? So you can see there, this came from the last page, how we multiply that out, and we got 345. That's the exact same as what we did from the last slide, right? So the important thing that we understand now is that this works with algebra. So here you can see I took the first term and I multiplied it by everything in the second. And then I took the second term and I multiplied that by everything in the second. Okay? And then I simply just multiply it out. So 10 times 20 is 200. 10 times 3 is 30. 5 times 20 is 100. 5 times 3 is 15. If I add all them together, I get 345. So the exact same logic works with algebra, and that's what we're going to look at next. So if you were to take this, for instance, okay, x plus 4 by x plus 2, I'm going to use the exact same idea as I used with my first sum, you could say. So I'm going to just do this one here in 2 different colors, and I'll just work it out. So I'll do x by x plus 2. Okay. Okay. I'm just going to change it there. So x by x plus 2 plus 4 by x plus 2. Okay. And that will give me x squared plus 2x plus 4x plus 8. So my final answer there will be x squared plus 6x plus 8. Because I can collect the like terms, I can bring them together. Okay. So that's just to show you where this comes from, show you where this grouping comes from. You can see there, the whole idea is to be able to see the shift from this to this, right? To be able to see how we can go from this to this, okay? And how we can go from that to that is we can break it up, and we can say the first term by everything in the second, plus the second by everything in the second, okay? When we're factorizing by grouping, we're actually doing the opposite. So we're starting with this line, you could say, and we're working backwards. Okay, so when we're factorizing by grouping, we're actually starting with the fourth line there and working backwards. So what I'm going to do here is I'm going to start with that fourth line that I was talking about, or the third line that I was talking about, and work backwards. So when we're factorizing by grouping, we have 4 terms. We need to piece the first 2 together and piece the second 2 together. Okay. What we need to do then is we need to factorize the first term. So we need to take out what's common in the first term. So in the first 2 terms, if you look at these 2 here, what's common to 2 of them is x. So I'm going to take x out. And I'll be left with x plus 2. Because x times x is x squared. X times plus 2 is plus 2x. I'm then going to take out what's common in the next 2. And what's common in the next 2 is going to be 4. So I'm going to take out a plus 4. Okay. And 4 goes into this, x plus 2. Because 4 times x is 4x. 4 times 2 is 8. Okay. You can see there that I've got x plus 2 and x plus 2. So I can go back a step there and I can write x plus 4 times x plus 2. So when we factorize by grouping, it's the exact same as expanding. It's actually just working backwards. So you can see there, if I had those 2 to be expanded, what I would have done is taken the first term and multiplied it by everything in the second, and then taken the second term and multiplied it by everything in the second. And if I multiply them out, I'd get x squared plus 2x plus 4x plus 8. Okay, so you can see there that what I'm actually doing, none of this should be new. It should just be a way of looking at this from a different perspective. Okay, so instead of looking at this going from expanding, we're looking at it from a different perspective, which is factorizing. So we're looking at it going backwards, you could tell. So what I'll do there is I'll move on. What they want us to do here, question 1, is they want us to factorize. Okay, so we can see here that we've got x plus y and we've got x plus y. So they're making this easy for us. They've done the hard work. We're going to do the rest. So in this case, I can say 2a plus 3 times x plus y. And like I said before, this is the opposite to expanding. If I was going to expand this, I'd say 2a times everything in the second, which is x plus y, plus 3 times everything in the second, which is x plus y. So you can see how that's the opposite there. We'll now look at question 3, or 2 even. So you can see there again, we've got 2a minus b and 2a minus b. So if I was to work backwards there, I can say that 3x minus 4 multiplied by 2a minus b. Now, if I was to work backwards here, I'd say the first, which is 3x, times everything in the second, minus 4 times everything in the second. So you can see how they link in, right? So none of this should be new at the minute. Question 3. So we can see here again. Between expanding and factorizing. Factorizing is the opposite to expanding. We'll get question 4 done. So if we look at question 4, 5y minus z, 5y minus z. So because I've got the same in both brackets there, I can say that 2x plus b all multiplied by 5y minus z. Okay. And again, if I was to expand that, I'd say 2x times everything in the second, which is 5y minus z, plus b, which is the second term, by 5y minus z. So you can see there how that's the opposite to expanding, and I'm sure everyone will be fairly okay with that. So I'm going to just move on there to the next couple of questions. So question 5, we'll do question 5, and then question 6 is one step further, right? So for question 5, let's quickly get that done. We can see here that we've got x minus 2y and we've x minus 2y. So if I was going to factorize that, I could say that I have 2a minus 1, because this here represents 1, okay, multiplied by x minus 2y. So the only trick there is that that value there is a negative 1, because you're multiplying this by negative 1, because it will be negative x and it will be positive 2y. So if I was to work backwards, 2a by x minus 2y by x minus 2y minus 1 by x minus 2y. Okay. And that brings us on to the next one, which is exactly where we need to be right now, right? So a squared plus ab plus ac plus bc. Okay, so you can see here that we've got 4 terms and we're looking to factorize. Okay, so if we have 4 terms and we're looking to factorize, we need to break it up. We need to take the first 2 terms and put them together and factorize them. And then we need to take the second 2 terms and put them together and factorize them. But what I like to do is I like to just underline the first 2 and keep them together. and underline the second two and keep them together. The reason why I do that is I think it makes it easier for myself to visualize what I'm actually doing, right? So if I look at the first two terms, what I need to do is I need to be able to factorize them. And when I say factorize them, what I mean is I need to take out what's common. So if we just look at those first two and think what's common with those first two is a. So I can take a out. Okay. And if I take a out, I need to know what's left. So it can't change its value. It has to have the same value. So I need to see what's this going to be if I take a out and multiply everything by a, what I'll be left with inside here. So a multiplied by something gives me a squared, and it's a multiplied by a. So that's the first term sorted. Now I need to see what happens with the second term. So a multiplied by something gives me plus ab. So that's obviously going to be plus b. And let's just double check that to make sure it hasn't changed in value. A times a is a squared. A times b is plus a b. Okay, so that's the first part dealt with. Now we're going to deal with the second part, which is AC plus BC. So I need to take out what's common to these two terms here. And what's common to those two terms is going to be C. So I'm going to take out a positive C, right? And if I take out a positive C, I need to see what I'm left with inside in the brackets here. So what I'm left with here is plus C times something gives me AC. So this is obviously going to be A. And plus C times something gives me plus BC. So this is obviously going to be plus B. And let's just double check that. So if we take C times A, we get AC. And if we get C times B, we get BC. So we know that works. Okay? And now we're left with this here, which is the same as the last few questions that we did. We've got a term inside the brackets, two terms there, which are equal. So this here and this here are equal. So I can write that down as A plus C times A plus B. And the reason I can do that is because if I was to expand that, I'd say the first term, which is A, times everything in the second, and the second term, which is plus C, by everything in the second. Okay? So, question 7. You can see there, in this question, we've got 4 terms, 1, 2, 3, and 4. So I'm just going to write out those 4 terms and we'll go from there, right? So, x squared minus ax plus 3x minus 3a. What I need to do when I have 4 terms is I need to take the first 2 and put them together, and take the last 2 and put them together. So if I look at the first 2, I have to take out what's common for the first 2, and what's common for the first 2 is x. So x multiplied by something gives me x squared. So x multiplied by x. X multiplied by x gives me x squared. X multiplied by something gives me negative ax, and it's going to be negative a. Okay, so x times x, x squared, x times negative a, negative ax. You can see what we're doing there, we're working backwards. Okay, I now need to take out the common term from my last 2 terms, and I can see there the common term is going to be plus 3. So plus 3 times something will give me 3x, and it's going to be x. And plus 3 times something gives me negative 3a. So it's going to be negative 3. Oh, sorry, negative a even. Okay. And you can see there again, it's like the last couple of questions we had. I've got this here and this here being equal. So I can bring them together. I can bring x plus 3 together. And you can see there, if I was going to expand that, I'd have x times everything in the second plus 3 times everything in the second. So that would be my expression fully factorized. Okay. I'm just going to do question 8 there. So with question 8, a plus b, or sorry, ab plus ac minus 5b minus 5c. So we do the exact same again. Take the first two terms and see what's common. And what's common in those first two terms is going to be a, b plus c. Take the second two terms and see what's common. And what's common in the second two terms is negative 5. So b plus c. So that gives us a minus 5 times b plus c. Okay, and just to look at that, if I was to expand that, I'd say the first term, which is a, times everything in the second, which is b plus c. Second term, which is minus 5, times everything in the second, which is b plus c. So you can see how that works if we were to expand. Okay, you're making me feel bad there now, James. That seems way too easy for you, is it? Okay, yeah. Okay, after spending 40 minutes of me going through stuff, you tell me that that you don't even need to be going through it. But look, at least I know you're doing fairly well. That's the main thing, right? Who did you have for maths last year, James? Oh, okay, Pierce is gone now, right? And how did you get on with the junior search? Were you happy enough with your results? Could have done better, all right. Okay, good man. Well, look, I'll leave you to it because you have another subject there, but good stuff. Okay, well done there for logging in, and we'll see you tomorrow, right?